So we are a little bit back in the time. So the following question is based on S and P block elements in the periodic tables. Okay. Identify the chemical species PQRS, TU, VW, X, and Y in the reaction scheme given below. Okay, now we will see how we can identify. This is very important to understand. Right. P is a white solid. Okay, fine, totally fine. So this is a white solid. And Q is, so when you heat it, Q is also a white solid, but it gives a colorless gas. Okay. So what do you think? What are the compounds that gives you colorless gases? For an example, this can be carbon dioxide, maybe SO2, and maybe nitrogen, maybe oxygen. These are colorless gases. Okay, so we don't know yet what is it. Okay, and so Q is a white solid. So this can be, if it is carbon dioxide, so this can be like let's say a salt like compound of either sodium carbonate type. Okay, this can be either zinc carbonate also, because all those are white in color primarily. And if it is SO2, it can be a sulfide compound. Okay, if it is like N2, it can be like white color solid like magnesium nitride, maybe, we don't know. And if it is oxygen, it can be like okay, it can be like nitrates maybe of group 1, not group 2, because nitrate of group 1 will give nitrite and O2. Aluminium, no, not aluminium. Yeah, that's all. And this Q white solid, when you add diluted HCl, you can imagine, see, now this is a white solid, and when you add diluted HCl, this gives a reddish brown gas. Now at this point, it gives the idea that this should be NO2 gas that is coming out, which means, because you know, when you have diluted HCl, this NO2 gas can be coming out from NO2 minus. So this should be NO2 minus that is present. So white solid should be, the anion should be NO2 minus. That is how you can identify. Why this is NO2 minus? Because you know, when you add diluted HCl, there are some anions that gives you these colors. Like for an example, we discussed about carbonates, bicarbonates, nitrites, sulfides. So reddish brown is obtained from nitrite. Okay, and there are some other products. And also you have Q, which is this okay, so we have Q, which is this white solid. So this white solid reacting with, so we know now in white solid we should have NO2 minus. Okay, when reacting with ammonium chloride, it is forming T, which gives white residue that gives a bright yellow color in the flame test. So what is the compound, what is the element that gives bright yellow color in the flame test? It should be surely sodium. So which should give you the idea, this should be Na plus. So this is NaNO2 reacting with ammonium chloride will give NaCl, principally NaCl. So the remaining one is ammonium nitrite. So you remember ammonium nitrite? Now at this point you should know ammonium nitrite, NH4NO2. When you heat it, it will give nitrogen plus water. Okay, so that is what they have done here. You colorless gas should be nitrogen and water is evaporating. So if this is sodium nitrate, so this should be the Q white solid should be NaNO2 which gives me the idea this is NaNO3, which we have predicted from this wrist. So the white solid is NaNO2. Okay. The white solid is NaNO2. So think about the way how we predict. We predict this one first with the white solid. We don't know what is it, but the colorless gases can be carbon dioxide, SO2, N2, O2, all these. And they have given something to identify this white solid, that is diluted HCl reddish brown gas. So NO2 gas is coming out, right? So NO2 gas should be coming out from NO2 minus. So which means in the white solid, there should be NO2 minus. Okay. And then they are telling this white solid which contain NO2 minus, when it's reacted with ammonium chloride, which is the ammonium plus and Cl minus, it gives a compound which gives bright yellow color in the flame. So it should be surely sodium. So surely this nitride should be sodium nitride. So if this is sodium nitride, so this compound should be sodium nitrate. Because when you heat sodium nitrate, you will have sodium nitride plus the colorless R gas, which is O2. Okay, this should be O2. And then when you have ammonium nitride, when you heat N2 and water vapor, so this is what they have mentioned here. And here also, when you have this oxygen, it is going to react with this V colorless gas, and it is also going to give N2 and water vapor. So in principle, you have to react something with oxygen to get nitrogen and water. So what is it? What do you think about this? At high temperature, this is also important. So what can you identify? So this is a very common reaction that we normally study. Okay. And then we have another thing. See, calcium reacting with U, which means nitrogens, which will give calcium nitride here, which is also a white solid. Okay. And calcium nitride with water will give calcium hydroxide, which is V here. You understand now what is this compound here to form this nitrogen U gas. So to identify V, they have given this. You understand what I am telling? You should understand, in fact. Okay. And magnesium plus R, which will give a white color solid. So you know what is R. So magnesium plus oxygen will give magnesium oxide. And magnesium oxide with water will give magnesium hydroxide, which turns our phenolphthalein pink because magnesium hydroxide is a base. It's a basic compound. Okay. So identify the chemical species PQR, STU, WXY in the reaction scheme given below. So you have to just take 1 point at each step and then analyze slowly. And if you know your analysis, basically these are analysis questions. Okay. I have told you many times, if you have the cation analysis and the anion analysis knowledge completely with all my notes, this is not hard. You can easily predict the results of this. Okay, try to understand that. Did you understand this? So did you understand this? How to approach this type of question? This is very important. The only thing is you should know your analysis. If you don't know the analysis and you try to answer this question, you are doomed. Okay. If you just learn S block and P block and try to answer this question, well, good luck. I would say good luck and goodbye also. You can't do that in that way. You should know cation analysis, you should know anion analysis, and it should be very well analyzed as well. Not just knowing. You should know what is actually happening here. What is the point of giving these questions? Okay. What is they are expecting? That is the most important question. Okay. Right. So next part. So we have three solutions, that is this test work done for the solution Z, and we will see what are the observation, and based on the observation we have to identify what are the reactions that is happening. So Ez is added to an acidified suspension of MnO2 to aqueous solution. Okay, so basically a pale pink solution with evolution of okay, so when I read this first statement, automatically it gives me the answer. That is how you should also be at the knowledge of this. Because this pale pink color, you can imagine the pale pink color is coming from MnO2, right? So the MnO2 should be reduced to Mn2 plus, because Mn2 plus is pale pink. So there is a reduction that is happening from +4 to +2. So there should be something in Ez that is oxidizing to O2, right? That is oxidizing to O2. This is 0. Okay. Can you tell me what is normally oxidizing to O2 in a solution? So I have one answer. What about others? What do you think? What is normally oxidized to O2? Because O2 is 0, right? So if you have like H2O, right? This is -2, right? So this -2 can be oxidized to O2. This is one that can be H2O. And the other one is the common one, that is H2O2, which is -1, which can be oxidized to O2. But normally water is not oxidizing. Basically H2O2 is the one that is get oxidized to O2, but H2O and H2O2 and H2O both can be oxidized. Okay, so from these two we cannot directly predict which is this. Okay, right. The next thing is passed H2S gas through the aqueous solution. A pale yellow, sometimes white turbidity, which means now again it gives the idea it is going from -2 pale yellow or sometimes white turbidity is sulfur. So it is oxidized. Okay, so this is oxidation, sulfur, -2 to this one. Then something in the solution should undergo reduction. Okay, something in the solution should undergo reduction. Now this confirms from these two the possible compound is H2O2, not H2O. Why? When this sulfide undergoes oxidation, the other compound, some compound in the aqueous solution of Ez should undergo reduction. But H2O is oxygen is already in -2. It cannot go undergo reduction, but hydrogen can be, but mainly we are dealing with oxygen here. So H2O2 can undergo reduction from -1 to -2, giving water, or either it can be oxidized from -1 to 0 to oxygen. So basically these two reactions gives us the idea here H2O2 in the first reaction acting as a reducing agent, and in the second reaction H2O2 acting as a oxidizing agent. Okay, this is the clear identification. And then pass SO2 gas through the aqueous solution, removed SO2 and added barium chloride, so there will be barium sulfate precipitate. Now automatically you should be understand, because when you add H2O2, this SO2 should be converted to SO42 minus. So you bubble away the excess one. Then when you add barium 2 plus, the barium chloride solution, this will give you the precipitate. Okay, barium sulfate precipitate. So these are the things that you should know. So identify Z. Z is H2O2. Give balanced chemical equation for the reactions that occur in test 1, 2, and 3. So you can basically write down the half reactions, MnO2 to Mn2 plus H2O, O2, O2. Write down the half balanced reactions, including electrons, then balance the electrons, then add and write down the overall reaction. This is same here for H2S. H2S going to sulfur, and the other one is H2O2 going to water. Write down separately, balance the electrons, then add. And here also SO2 to sulfate, and this is the oxidation, and the reduction should be H2O2 to water again. And then you need to balance the electrons and add those half reactions. But here additionally you should also show this reaction as well, right? Barium chloride plus sulfate, barium sulfate plus Cl, 2Cl minus, that is formed here. Okay, that is this. Give two uses of Z. So we have already seen the two uses. So it can be used as oxidizing and a reducing agent. And H2O2, you know, when you fall down, some cases wounds and those things happen. So when you have such a situation, we give H2O2 as a disinfectant. You just keep it, because when you apply this, any bacteria or fungus that is present around that area will get oxidized basically and kill it. So this is where this good disinfectant, in fact. And what is the most important intermolecular force that is present in H2O2? So basically H2O2 is this. So you can imagine what is normally present in H2O2. Okay, there are lone pairs here. Okay, and hydrogen is there, so it can form another, like a network with another H2O2 molecule. So what is the prominent one? What is this? Hydrogen bonding. Okay, so it's mainly consists with the hydrogen bonding. Okay, so did you understand this part also? You should be. Okay, I guess yes. So the idea of approaching here is you need to identify primarily in the first test what is going to form oxygen. That is first one. Second one, from the second statement, you need to identify something that is in Z can undergo either oxidation as well as reduction, because here it is reduced, here it is oxidized. So more or less you can find it should be H2O2. Okay, and the third one, it again confirms the ability of H2O2 to oxidize SO2 to SO4 minus, which gives you the precipitate as well. And part C, the following procedure was used to determine the thickness of a layer of chromium coated on a surface of a rectangular sheet. So there is a rectangular sheet and there is chromium coated on top. And we use basically the dilute acid. So you can use either HCl or H2SO4. And you have given the dimension. So this is 18 to 5. And if you think the thickness is like, let's say X for an example, or the Y. The resulting chromium 3 plus was oxidized with S2O3, S2O3 peroxide disulfate, so S2O8. Okay, yeah, S2O8 in neutral medium, so it should be like the medium that you necessarily think. And you have given the reaction as well, so no problem in predicting the result. After removal of excess S2O8 2 minus, the solution was acidified, and excess of ferrous ammonium sulfate, so you have given a big formula, 3.10 gram was added, and the unreacted Fe2 plus was then titrated with dichromate. and the volume was given 0.059. Give the balance equations for the reaction of chromium 3 plus with S2O8 2 minus and Fe2 plus with dichromate. So this reaction is common. What you have to do here is you write down Fe2 plus and you write down the oxidation, that is Fe3 plus plus 1 electron. And dichromate Cr2O7 2 minus, since the condition is acidic, it will go up to chromium 3 plus. So this is the oxidation, and the reduction is Cr2O7 2 minus will be giving chromium 3 plus. Then you can separately balance these two and add. This is the second reaction. The first reaction is, think about the first reaction. Okay, chromium 3 plus reacting with S2O8 2 minus. Okay, so chromium 3 plus S2O8 2 minus. Okay, what is the purpose of adding iron 2 plus with ammonium? This basically the ferrous ammonium sulfate. So what is the purpose of adding this ferrous ammonium sulfate? That is one important thing that you need to identify here. Okay, because when you dissolve all chromium 3 plus, so you have chromium 3 plus solution, okay, then you add this one. Basically, this chromium 3 plus can be converted to this dichromate, and your peroxydisulfate will go to sulfate. That is one thing that is normally can happen. Okay, so in the solution you have dichromate and sulfate. That is one thing. Then you remove this excess, then you acidify, and then you add ferrous ammonium. So if you add ferrous ammonium, there is Fe2 plus here. Okay, that is titrated with K2Cr2O7, that is unreacted. This is an important point to understand. What do you mean by unreacted? That is very essential to identify, because initially there was chromium 3 plus, and when you add peroxydisulfuric, it formed dichromate and sulfate. So there is no problem in that, right? But here, then S2O8 is removed, but you are adding excess of ferrous ammonium sulfate. So excess of ferrous ammonium sulfate, and you have given the mass also, which means you know the initial excess amount of ferrous ammonium sulfate. You can calculate the number of moles by dividing this by the molecular weight. Okay, and then you have given another procedure to identify how much excess unreacted Fe2 plus was there. Okay, so by the difference of these two, the initial amount of ferrous ammonium sulfate and by the unreacted one, you can calculate the amount that is reacted. Okay, so if you know that the amount that is reacted, you can automatically find the chromium 3 plus concentration using the balanced chemical equation that you write here. Chromium with S2O8 2 minus. Okay, so I will explain that. Wait, give me a minute. The idea is it is easy for me to use the board here. So the idea is this, right? So we have mainly the two basic reactions. One is ferrous reacting with the dichromate, and chromium 3 plus that is reacting with the sulfate. Okay, So in principle, you have chromium 3 plus, okay, that can be converted to Cr2O7 2 minus. That is one of the reactions. And the other one is S2O8 2 minus, that can be converted to sulfate. SO4 2 minus. So this is a typical reaction. So here you have one chromium, so I'm going to put 2 here. And there is 7 water here, so 7 oxygen. So I'm going to put 7H2O. And here to this side, I will put 14H plus, right? So you can imagine this, the normal reverse reaction of the thing that we are going to happen. We are going to write actually. And then you need to balance the charges. So here there is plus 6. And here there is plus 12. So I will add 6 electrons to this side. And here also very similar, there are 2 sulfurs. So I'm going to add 2 sulfur here. Then oxygen is balanced. So I just need to add the charge. So there is 2 minus. Here there is 4 minus. So I'm going to add 2 electrons to this side. Okay. Then I just need to multiply this by 3 to balance the number of electrons. So this will be 3 here times 3 to make the 6 electrons. And 2 into 3 means 6. Then you can add these two. Okay, so this is one of the reaction that is going to happen here. Okay. The other reaction is if you have Fe2 plus, it will go to like Fe3 plus electron. This is the oxidation. And the reduction is Cr2O7 2 minus going to go with chromium 3 plus. So again, 2 chromium, 7H2O, 14H plus, the same thing that the reverse. You need to understand, right? That is why they have given the initial amount and the unreacted, because based on the difference, you can combine to these 2 equations. Okay. So here everything is correct. So then you can add the electrons. Since there is only 1 electron, there will be 6, 6, 6. Then you can add these 2. So this is one of the reactions. This is the other reaction. So we have 2 reactions for this particular question. So you can imagine the thickness is like X, as I explained here. I will share the screen again. Okay, so if you have any question, you can put in the chat box as well. Right, so basically you can imagine the thickness is like let's say X for an example. Then you can multiply 8, then Y 5 centimeter times the what do you call the height as X, then you can find the volume. So if you think that is the volume, you can multiply it by the, let's say you want to calculate the weight for an example, let's say. So what should be the weight that you can have? You know the area, it will be 8 into 5, it will be 40 here. And then you can understand the thickness when you multiply it by the thickness, let's say that is Y or X or anything, then you can find the volume in principle. And then if you know the weight of it, then you can find the mass of it as well. Okay. So how do you calculate this? That is the important part to understand this. Okay. So you have 2 reactions. That is, I will stop sharing here. So this is one of the reaction that is happening, right? So you dissolve this, you add this, Cr2O7 2 minus is formed. No problem in that. Okay. And here you have Cr2O7 2 minus. That is again going to be converted to chromium 3 plus with reacting with Fe2 plus. Now this is unreacted amount of, remember, you know this. You know this. How you know this? Because it is given. See, it is given 3.10 gram. So you can calculate the molecular weight of this. For that, they have given the molecular masses here. So you can calculate how much ferrous ammonium sulfate is here. 3.1 gram. I will just calculate the values, so it will be very easy for this. So the molecular weight is 392 gram per mole, and 3.1 you can divide it by 392. This will be the Fe2 plus moles. So you can imagine, if this is Fe2 plus moles, how much dichromate that is going to be reacted. It is in fact 1/6 times that is going to be reacted, right? So this will give the amount of unreacted that is present in the solution. Okay. So if you know the Cr2O72 minus that is already present in the system, if you know the unreacted and the initial amount, you can calculate how much that is reacted. So you can equalize that to Cr2O72 minus, which will be the difference. And if you know the difference, you can get the stoichiometry as 1/6, and then you need to know the entire mass, which is now 18 to 5 into some thickness into the weight. So that's all. Okay. And don't forget, they have given the density of chromium here. This is to find the mass of the chromium that is present on the thickness. Because if you know the area 8 into 5, you know the area. So if you think the thickness is x, so it is basically 8 into 5 into y. So you know the volume. So they have given for 1 cubic centimeter, the chromium weight is 7.2. So to 8 into 5 into thickness x volume, you can multiply this by 7.2. So you know the mass of it. So if you know the mass of it, in the reverse, you can calculate mass of the chromium 3 plus using this calculation. So if you know the mass here, the only thing that you don't know with the mass here is the thickness. You can substitute it and find the thickness. Okay.